The content from this video is found from videos on the Electrical Code Coach's YouTube channel. Be sure to check out his channel as well as his videos. This will be a remake on the information found in his videos. I'll do my best to include everything that he did in his videos, as well as try to explain some things that I think might need some explaining. So be sure to check out his original videos on the same topics. The link will be in the description. Welcome to this video all about box fill. We're first going to learn about rules. Then we're going to tie into the rules with questions which will act as a review as well. Okay, so let's not waste any time. So starting off with the rules. How to count conductors, devices, and fittings. Grounds do have separate values. So first we're going to be talking about hot and neutral here, and then we'll talk about grounds and those rules separately. So with hot and neutral, each conductor counts as one conductor of that gauge that you're working with. Also, each conductor that passes through the box counts as one conductor of that gauge. This means even if it doesn't terminate with anything inside of the box, but it just passes through the box, it still counts as one conductor of the gauge that it is. Now pay attention here, internal clamps. S is circled because it doesn't matter how many clamps you have. If you have a box, your internal clamps count as one conductor based off the largest conductor. So if you have 3 clamps and your largest conductor is number 12, you will count one additional number 12 conductor. And if you have 1 clamp and your largest conductor is number 12, you're still, again, going to have one additional conductor counted based on that largest conductor, the number 12. And of course, external clamps are not counted for box fill, only internal clamps. Okay, so we see that when we're using a clamp, we're counting it as one conductor based off the largest conductor, so we can actually size it as that largest conductor. In other words, this is going to enable us to give this an actual size, so then we can form a calculation with it. This is going to make a lot more sense when we get into the questions in the second part of this video. Okay, next rule is that each stud or hickey present on a light brace shall be counted as one conductor based on the largest conductor in the box. Okay, so I did my best to draw this. I'm also going to include a picture, but I can point to this right here, and that's that we see, we're imagining this is a light box, which as we know, a light box is a circle, and we see that what is supporting this, what is called this hickey here, that is supporting then this nipple that is supporting the chain, supporting a light, is this stud. And we see the stud is just like a nipple, but it's called a stud because it is what is inside of this box connecting to the hickey. Okay, and we see we are not counting this external nipple here that is connected to the chain. We're counting each stud or hickey, and this should actually say and. So each stud and hickey present on a light brace. Okay, so for in this example, we're going to be counting the stud as one conductor and the hickey as one conductor based on the largest conductor in the box. And we do see some conductors in the box. We see another nipple here where we see some wires coming out of, and they're connecting to the wires that are going to what would be going to this light. Okay, so just remember this is very old-fashioned terminology, but this might show up on the test when they mention the fact that there's a stud and a hickey, or maybe just either one of them. Okay, next, when you're looking at a device, in this case we're looking at a Decora style receptacle outlet, and we notice something when we're looking at the device is that our outlet as well as our switches are going to have these thin pieces of metal on the outside, which is of course where you screwed the device into, the actual box, but furthermore than that, it is also bonding together an entire piece of metal on here, and this is known as the yoke, Y-O-K-E. This can also be known as a device strap. Your yoke or your strap actually goes throughout the device, and if you notice when you look at your outlet, you will see a piece of metal on the side of your device as well, and that is actually where it is bonded to this yoke as well. Here's a picture of what an actual yoke looks like in a device. You can see it's one solid piece of metal that goes through basically the back of the device, up through the top and the bottom to where you actually screw the device in, and it is bonding, or what some people call grounding, the device. Okay, next rule is that each yoke or strap counts as 2 conductors based off the largest conductor connected to the device. Pay attention that it is connected to the device, and this makes perfect sense because we're talking about the actual yoke or strap of the device. Okay, so makes perfect sense. This means that we could think of this as each gang of devices, like we call a single gang, double, triple gang, quadruple gang, where we put devices in such as switches, and we could think of each gang as two. So we have a two gang. That means we have 4 additional conductors counted for the yoke slash strap based off that largest conductor connected to each of the device. This means if we have a switch box that contains 2 different switches, let's say the first one is number 12 and the second switch has number 14. Then the first switch is going to count as 2 number 12s, and the second switch is going to count as 2 number 14s. Since on each separate device, the largest conductor is number 12 on the first one and number 14 on the second one. Okay, now we have the equipment grounding conductors, or known as EGC, and this is going to be relevant for the NEC codebook 2020 and up. The 2017 version and before that went by a different rule, so if you want to check that, then make sure to look into the 2017 codes for the EGC in Boxville. But again, this is going to go for 2020 and past. Up to the first 4 count as 1 conductor. Every 1 past 4 is counted as 25% volume. So if we have 6 conductors, then the first 4 of those will count as 1. There'll be 2 left over, and depending on what size that wire is, the volume of that is going to be rated by 25%. Okay, and this is actually pretty simple. Okay, so now the questions. We want to find the total cubic inch volume for a light box containing 3 number 12 conductors, 1 stud, and 1 hickey that are present in the box. Okay, and remember, work smarter, not harder. So let's think logically about this. We have 3 number 12 conductors. Those are the only conductors we have, and we also have the 1 stud and the 1 hickey. But we know that those are based off the largest conductor that is in the box. So if we think about it, we have the 3 number 12s, and then we have another 1, 2 conductors that we're going to be counting as number 12 added to that. So we could just look at this as 5 number 12 conductors, because that's how we're going to count this. Number 12 is counted as 2.25 cubic inches as of table 314.16b. Since we're doing box fill and we're doing the cubic inches, we are using this table here. 5 times 2.25 is 11.25 cubic inches, and that is our total cubic inches for this light box. Okay, next, what is the total cubic inches for a light box with 3 number 12, 3 number 14, and 1 hickey present in the box? Okay, so we know the number 12 is 2.25, and we have 3 of those. So we're going to do 3 times 2.25, figure out what that is in a second here. But we also have 3 number 14, and we know the 14 is 2 cubic inches, so we're going to do 3 times 2. We'll also do that in a second, and then we just have the 1 additional hickey, which I'll just put 1h. This is based off the largest conductor, which we know is going to be in size the number 12. Of course, if you're used to this and you think about number 12 and number 14, you probably don't think about it twice. But in fact, the number 14 is a larger number, but it's a smaller gauge of wire. One of those weird things you just gotta know. Okay, so we have 2.25 because that is the size of the largest conductor, and we're just counting it as 1 of those because we have 1 of those present in the box. Okay, of course, 3 times 2 is 6, and then 3 times 2.25 is 6.75. Now we're going to add this all together. So we have 6.75 plus 6 plus 2.25. This is all going to equal 15, and this is cubic inches. And now we know the total cubic inches. Okay, next question. We have the total cubic inches for a light box with 8 number 12, 2 single pole switches, and it is a 2 gang. Okay, so we can break this down. We're looking at 2 single pole switches, and we know it's a 2 gang. So we can think of the 2 gang. 2 per each gang means that we have 4 additional conductors based on the largest conductor to the device, or we can think of the fact that we have 2 single pole switches, which again have that yoke or strap, and each one of those will be counting as 2 conductors based on the largest conductor to the device. Whatever it is, we got to keep in mind that we're not going to do both of those, because then we'll have twice as many. So I'll just forget the fact that it's a 2 gain, because I like to just kind of think about things logically here. And okay, I have 2 single pole switches, so I know that I have the strap or yoke, and I know there's 2 conductors counted as each one of those. So I know 2 single poles, now I have 4 additional conductors. I know those conductors are based on the largest conductor to the device. The only thing I'm working with is number 12. So now instead of having 8 number 12, I have 8 plus 4, which means 12 number 12 wires, okay? And because I have 12 number 12 wires, I'm going to do 12, my number, times the size of the cubic inch value of the wire, which is the 2.25. 12 times 2.25 equals 27 cubic inches. That is the total cubic inches for this light box. Okay, next we want to find the total cubic inches for a light box with 8 number 12 conductors, 2 single pole devices, 6 number 14 conductors, and 2 single pole devices. And this is going to be a 4 gain, which makes perfect sense. Now, since 2 of the single pole switches are going for the 12 gauge and 2 are going for the 14 gauge, I'm going to split it up as shown here. So I have the 2 single pole switches for the number 12, so I'm going to have an additional 4 plus my 8 that I already have. So I'm going to have 12 number 12 conductors. So I'm going to have 12 times 2.25. 2.25 is the cubic inch size for the 12 gauge wire. Next, I have my 6 number 14, and I have the 2 single pole switches. I again know that I have additional 4 conductors based on the largest conductors going to that device. Because of this, I know I have my 6 14 gauge conductors along with my extra 4 for the 2 single pole switches, which is going to give me 10 14 gauge conductors. So then I need to multiply that by 2 for the cubic inch size of the 14 gauge conductor. Obviously 10 times 2 equals 20. There's one of my values. Then 12 times 2.25 equals 27. Okay, so there's my other number. Now I'm going to want to do 27 plus 20, and, well, it's simply going to be 47 cubic inches, and that's going to be my total cubic inches for this light box. Okay, next we want to know the total cubic inches for a light box with 3 internal clamps and 4 number 12 conductors. Since we know we only have number 12 conductors, then we know that our 3 internal clamps will turn into 1 conductor based off the largest conductor. So we have 1 conductor based off the size of the number 12. Because we already have 4 conductors based off the size of the number 12, plus the additional 1 from the internal clamp, all we got to think is the 4 conductors plus the 1 conductor equals 5 conductors rated at 2.25 cubic inches, and that's going to give us 11.25 cubic inches. That is the total cubic inches for this light box. Okay, now we're looking at the equipment grounding conductor questions based off the rules on the code book from 2020 and above. What is the total cubic inches for a box with 7 equipment ground conductors that are 12 gauge? Okay, so we know the first 4 are going to count as 1. So let's just think we have 4 of these. This is going to count as 1 at 12 gauge. So we have 1 conductor that's going to be rated at 2.25 cubic inches. Because of that, we could think we already had 7. We subtracted 4. Okay, we're going to have 3 conductors left over. We can simply rate these conductors at 100% to begin with, just to make this simple. Don't really overcomplicate this much. 3 times 2.25 is going to give us 6.75. But we need to rate all of the conductors over 4 conductors at 25% or a quarter of the percentage. Because of that, we're going to get the 6.75. We're going to multiply that by 0.25. 5. That's going to give us 1.6875. Now we need to know the total cubic inches. So we also need to add this number, which is from the first 4 equipment grounding conductors. So we're going to add the 2.25 to the 1.6875. And from there, we're going to get 3.9375 cubic inches. And that is going to be the total cubic inches for this box with the 7 equipment grounding conductors at 12 gauge. Okay, next we want to know the total cubic inches for a box with 6 hot, 6 neutral, and 6 EGCs all at 12 gauge. Okay, so we know with the hot and the neutral, each one conductor is counted as one conductor of that gauge. So we have 6 hot, we have 6 neutral. We obviously know that 6 plus 6 equals 12. So right off the bat, we have 12 with the hot and the neutral. What we have left over is the 6 equipment grounding conductors. Everything is at 12 gauge. So we're going to get the 6 and we're going to subtract the first 4. We're going to have 2 left over, and the 4 that we subtracted is going to turn into 1 rated at the 12 gauge. Okay, so now I have 1 conductor rated at the size of the 12 gauge, so 2.25 cubic inches. And then I have my leftover 2 conductors that are going to be rated at the quarter percentage or the 25%, same thing. So now my number 4.5 needs to be multiplied by 0.25. Okay, and that's going to give us 1.125. So now we know the rating for the EGC. We have the 4 rated at the 12 gauge, and we have the additional 2 rated at the 12 gauge at 25%. Now we need to know the size of the 12 hot and neutral number 12 conductors, and we know that the number 12 is 2.25. So we're just going to take 12 times 2.25, and we're going to get 27. Okay, now that we have that, 27 plus 2.25 plus 1.125 equals 30.375 cubic inches, and that is the total cubic inches for this box with the 6 hot, 6 neutral, and 6 equipment grounding conductors all at 12 gauge. Okay, so that's it for this video. If you enjoyed it, give it a thumbs up, share it with a friend or on social media, and be sure to check out my other videos. I am posting about 7 videos all at once right now, so quite a lot of stuff, and I've been posting a lot of stuff recently on some very important topics for electrical theory or electrical engineering. Stay tuned for more videos, subscribe for more, and until next time, goodbye.